All right, let's get to geometry homework. So we're going to use the picture to identify all the things that's happening. Okay, MO bisects LMN, right? Anytime they tell us something like this, we just can't ignore it, right? It means something very specific to the picture. So MO, it bisects the angle, meaning it cuts it in half and the angles are equal. LMO, so LMO, LMO is 2x minus 10. NMO, the other side, x plus 15. Okay? So let's figure out what x is. So since the angles are equal, we can set them equal to each other. So 2x minus 10 is equal to x plus 15. Solving for x, putting all the x's to one side, all the non-x's to the other side. X is equal to 25. So I want to figure out what the actual angles are. So we have to plug this back in to one of them. So 2 times 25 is 50, minus 10 is 40. So the measure is 40. Since they're congruent, they both have to be 40. But you could check yourself if you want. We could plug in 40 here, not 40, sorry. 25, 25 plus 15 is 40. Okay. SV is the bisector of TR. Okay, so that means that these are equal. That means these are equal. And that means these are equal. The bisector is powerful. If you tell me something's a bisector, then immediately things are going to start being equal. Not only that, but these angles are equal. Okay. What do they say? PR is 5. TV is 8. And PVT. Okay, so this angle right here is 30 degrees, which means this angle is 30 degrees. That's just implying it, right? All right, so TP, change colors. So everything in red is what they gave us. Everything in blue is what we deduced, right? Like we figured it out, basically, based on facts and logic. So TP is also 5 because they're congruent. VR is also 8 because it's congruent to TV. And the measure of VRT, where is VRT? VRT is down here. So this angle, what is this angle? Okay, so to figure this out, we have to know that a triangle has 180 degrees, right? The measures of the angles, all three angles, add up to 180. Since SV, oh, I guess we forgot to put this symbol. This is a perpendicular bisector, right? So it's actually 90. So this is 90 degrees. So a triangle must have 180 degrees. So minus 90 because we know 90, and then minus 30 because they told us 1 is 30, right? So we have 30, 90, and the unknown. So they have to add up. All three of these have to add up to 180. So this is going to be 60. VRT is 60 degrees. Okay. Use the figures to fill in the blanks. All right. Segment CD is a bisector of ABC. So that's why these are congruent. Okay? That implies that these are congruent, because any point that is on the bisector is equidistant from the endpoints of the other segment. All right. If it's on the bisector, which it is the bisector, right? So this is a very powerful theorem that we're using right now. Okay, measure of BCD. So where is BCD? So C is the vertex. So I'll use blue. So B, C, D. So this angle right here, that's what we're looking for. How much is this angle? Well, that angle is going to equal this angle. And again, we know that there's 180 degrees in a triangle. The box is suggesting that it's 90 degrees. And then they give us 35. So minus 35. So we get 55 degrees. The measure of BCD is going to be 55 degrees. And that's because this angle is 55 degrees. Therefore, this angle has to be 55 degrees as well, right? Because they're congruent. Okay. Next, AC is 5 centimeters, right? Because it is congruent to CB. So AC is 5. Segment MO bisects segment LON. All right, so it's already marked for us. Some things to consider. What's congruent, right? These are congruent. These are obviously congruent. And then these are congruent. Well, technically, it's not congruent, right? Because there's nothing that is congruent to. But both triangles share a side. So one triangle, yeah, never mind. We'll leave it at that. Okay. ON. Where's ON? ON is here. I guess I could have done it in blue. ON is here. And since it's congruent to OL, that's 5 inches. Two marks mean inches. LM is here. It's congruent to NM, so 7.5 inches. Okay, 11 and 12. BD is an angle bisector of ABC. So these two angles are congruent to each other. They're the same measurement. So the arrow's pointing to one side. So like for instance, the black arrow is suggesting that this is x plus 15, not 5, I'm sorry, x plus 15, which means this angle is x plus 15. Here they're saying the measure of ABC. ABC is the whole angle, right? The whole angle. ABC. So if you add these two together, x plus 15 plus x plus 15, this should equal the whole angle. 4x minus 6. So if we combine like terms, x plus x, 2x, 15 plus 15, 30, this should equal 4x minus 6. And now we're just solving for one variable, right? Two-step problem, I guess you could say. Minus 2x minus 2x. 2x minus 6 is equal to 30, because it cancels. Plus 6 plus 6. 2x is equal to 36. Divide both sides by 2. X is equal to 36 divided by 2. 18. So x is equal to 18. So to figure out what ABC is, we have to plug in 18 into x. So 4 times 18 minus 6. 4 times 8 is 32. Carry the 3. 4, 5, 6, 7. 72 minus 6. which is 66. So ABC is 66 degrees. I know that one went quick, but you can always pause the video. All right, to the back, or page 2. All right, we're going to use the figure to the right and the following information. Okay, let's see. What is it saying? DF, DE, DC are perpendicular bisectors of ABC. Triangle ABC. Okay? And D is equidistant from each vertex. Okay. DC is 2. So DC. Okay, that one's interesting. So here, this is 2. AC and BC are congruent. Find the measure of A. All right, so some different things are happening. Let me think. All right, so what are some things we can do? Right, all of these are going to be congruent. Is it though? That's the question. Is it though? Are DE and DF, well, D and DF are going to be equal for sure. But are they equal to the other ones? That's the question. All right. The tick marks are giving me anxiety. Sorry. It just looked crazy. Okay, so find the length of, what do we want to find first? Oh my goodness. Okay. Let's do this. I know that this is a right angle. Can we say, do we know that these are, I feel like this is a square. I feel like it is a square. You know what? It is a square. Because if it is a perpendicular bisector, I know it's kind of off, but these angles are going to be congruent, which means they're going to cut it in half. And it's a 90-degree angle, so each of these are 45. That's actually pretty nice. Which means each of these are 45. Right, and because this is 90, right? Here, this would be 90. Okay, so yeah, so there's a lot of symmetry happening right now. Okay, so if we use Pythagorean theorem, can I use Pythagorean theorem right now? Actually, so find the measure of ADC. So ADC, that is, look, I'll do it in green, or red rather. ADC is this angle right here. This is in fact a right angle because it's a perpendicular bisector, right? So this is 90. ADC is 90 degrees. AD, okay, so here, let me take off some of these lines so you can kind of see what's happening. Okay, so this was 2. All right, AD is this section right here, this segment. All right, this segment is also 2. And that's because DF is a perpendicular bisector. So D is equidistant. D to C, D to A. They're the exact same distance because this is the perpendicular bisector. Right? That's what they told us here. DF is a perpendicular bisector. So that means it's equidistant to each vertex. That's what it tells us. So AD is 2. Which, because it's symmetry, right? Properties and symmetry, this is going to also be 2. So AB, 2 plus 2, which is 4. Okay, this is nice. This is nice. Find the length of AC. Where's AC? AC is this side. Use Pythagorean theorem. That's our hint. What else could we find? Oh, BC, I guess. Okay, so let's do it like this. There's 2 ways that we can think about this. If this is unknown and this is unknown, right? Pythagorean theorem tells us that x squared, right? A squared plus B squared, both of those are x's. This should equal C squared. So this is going to be 2x squared equals 4, which when we divide both sides by 2, we get cancels, reduces, x squared is equal to 2. So now when we take the square root of both sides, because that's the only way to undo a square, we get x is equal to plus or minus the square root of 2. Right? You have to do plus or minus anytime you bring a square root. That's just a known algebra thing, right? So we can actually exclude the negative. And it's because we're doing distance, and distance can't be negative. So really, we're just going to say x is equal to root 2. So all these sides, this is rough. Right, x is equal to root 2. Which means this is also root 2. Right, all these little lines here. So this one, this one, this one, this one, this one, this one. They're all root 2. Whereas this guy, and this guy are 2. So root 2, square root of 2. Okay, so we need to figure out what AC is. AC is root 2 plus root 2. Okay, this is hardcore. So we really haven't gotten to this that much yet, but anytime you're adding square roots, just treat it like a variable, right? If this was x plus x, it would be 2x. So root 2 plus root 2 would be 2 root 2. So 2 root 2. And BC is exactly the same idea. 2 root 2. Man, that's hardcore. That's you might have to watch that one a couple more times. Are we at the last one yet? No, we got two more figures. Okay. Use the figure right and the given information. XT, ZS, WY are angle bisectors. So that means the angles are going to be congruent. So XT. So this angle is congruent to this angle. ZS. So this angle and this angle are congruent to each other. Now the question is it equal to the other side, right? XZ and WY. So these are congruent also. These are congruent to each other, right? To each other. Okay. And Z or XWZ, triangle XWZ. Okay. V is equidistant from all three sides. Okay, so V is equidistant from all three sides. So that means this, this, and this are all the same. VT is 3. XW is congruent to WZ. So this side is congruent to this side. Those are congruent. And the measure of WXT is 20 degrees. So this angle right here is 20 degrees. WXT. All right, there's a lot going on. All right. So find the length of VS. So VS. Well, that's 3 because it's congruent to VT. TXZ. So this side, TX and Z, is also 20 because it's congruent, 20 degrees. WXZ, that's going to be the combination of both. So 20 and 20 makes 40, right? Because this is 20 also. WZX. Since WX and WZ are congruent, it's safe to say that these are also 20 degrees. Right, because they tell us that the sides are congruent. So if the sides are congruent, there's a lot of like symmetrical things that are happening. So WZX is going to be 40. Right, that's the whole angle, WZX. SZX. SZX. Okay, that's 20. Right, SZX. I'll do it in green. S, Z, and X. So that's 20 degrees. And then XWZ. XWZ. Okay, so that's the whole angle up here. This whole angle. Okay. If this is 40 and this is 40, so we need 180 in one triangle. So if both of those are 40, so 40 and 40, this would be 80, right? 80. So when you subtract, we get 100. So now you may say, okay, this doesn't look like an obtuse angle. Well, you can't always trust the picture, but you can for sure trust the math. So that's a very hardcore geometry lessons. You can't trust the picture ever, but you can always trust the math. All right, the last figure. If AF is 2x minus 5, so 2x minus 5, and BD is x plus 1, so x plus 1, and the perimeter is 56. Okay, this is the perimeter is adding up everything all the way around. So a couple things to note. This side is also 2x minus 5, and this side is also x plus 1. Right, because that's what the tick marks mean. Okay, find x. Well, I'm going to use the fact that they're congruent, right? I can use either one, but I'm going to use the x plus 1s to figure this out. x plus 1. Oh, look, I missed one. AE. Where's AE? AE is x. So that means this is x. Okay, so to figure out what x is, that actually brings up a new strategy. So the perimeter is all the sides added up. So I'm going to add up all these x's and numbers. So this is going to be, wow, 2x minus 5 plus 2x minus 5 plus x plus x plus 1 plus x plus 1. Wow, that is pretty insane. We just combine all the like terms, and this should equal 56. So look, let's do it like this because this is kind of out of hand. So let's do it like this. This side, AB, is x plus x. So this is 2x. This side is x plus x. So 2x plus 2. Right, we're just combining like terms one time. All right, 2x plus 2x is 4x. Negative 5 minus 5 is negative 10. All right, when we add all these up, this should equal 56 because the perimeter is 56. So this is going to be, I'm going to switch colors. 2x plus 4x minus 10 plus 2x plus 2. This should equal 56. So combining all the x's, 2, 4, 8. So 8x. Combine all the non-x's. Minus 10 plus 2. So negative 8. This should equal 56. I'm going to add 8 to both sides to solve for x. We're going to get 8x is equal to 56 plus 8. 64. Oh, that's nice. Because look, divide both sides by 8. X is equal to 8. So we're just plugging in 8 now into x to figure these out. So let's do the easy ones. AE and EB. So AE is 8. AB, well, there is no EB, but AB, 8 and 8 is 16. Okay, what's next? AF. AF. So 2 times 8 minus 5. So 16 minus 5, which is 11. So AF is 11. AC, 22, is double. And then lastly, A or BD. BD is 8 plus 1. 8 plus 1 is 9. So BC, 9 and 9, 18. That one was fun. That one was fun. All right. Remember, perimeter is all the way around. Okay. Hopefully this helps someone. Catch you guys in the next video.